Heather Kaminsky is our next speaker. Heather gave me an excellent bio, which I'm going to ignore and do my own version of. I'll capture the essence. Heather's now a decade with oil sands experience, product of, a very positive product and experience early going at the Oil Sands Tailings Research Facility, where she got her PhD, and she was focused on the heavy characterization of the heavy minerals in the froth treatment tailings, not the heavy metals, heavy minerals. And from that, developed a passion for the characterization and the seeking to understand the fundamentals of clay. So she spent time with Total working on that space, had a sojourn from the detailed research into the tailings planning to get the practical aspects of the business with Total, and has recently this year shifted over to Suncor, where she's back on the fundamentals agenda. My commentary, the fundamentals, particularly, we'll just keep touching back on Brent's talk. If we don't understand the fundamentals of the clay, then we can't manipulate the clay to get the water release that we seek in an efficient, cost-effective way. So it all does go together very well.
So today I get to be the sacrificial lamb for the Deposit Characterization Subcommittee, or rather the willing volunteer, because I love giving presentations. So this work was a committee done by through COSIA, and I'm reporting on the works of this committee. I'm pleased that several of my committee members are in the audience, including Ted Lord, Wayne Mimura, and Paul Kavanagh, who's over there. A few were not able to make it. Other members of my committee are Mohamed Al-Mamoun from Suncor, Michael Graham from Shell, Reza Salahi from CNRL, Hanif Mian, working on behalf of CNRL, and Africa Garamou on behalf of the AER. And I was really privileged to be able to work with these fine gentlemen on this work. So Directive 74, as you know, specifies that 50% of fines in an ore must be captured in a dedicated disposal area, which will achieve an undrained shear strength of 5 kPa within 1 year. This has begged the question, how is 5 kPa measured? Is it a peak over molded number? And how do you apply it for deposits in these suite of technologies that are not fines dominated and therefore not necessarily drained or undrained? So the industry recognized that there is a need for standardizing these tailings measurement to support both the regulatory reporting and to support clarity and technical discussions between operators. So the committee was struck with the objective of selecting an in situ measurement method to measure different tailings deposits performance which meet or exceed Directive 74 requirements for each tailings type. And the tailings type were defined as according to the oil sands classification chart, which was one of the COSIA documents that has been completed for a long time but not yet publicly available. And basically we have fines dominated materials in the brown there, and that's anything with a sand to fines ratio less than 1. We have the blue area is sand deposits, which is anything with a sand void ratio less than 1. And then you have the two fluid regions that are sand dominated. We have transition material, which is in yellow, which is a sand to fines ratio between 1 and 3. And the green area is more sandy, segregating sand, which is a sand to fines ratio greater than 3. And we were supposed to propose a method for each of these deposits. So it was really important to first define what it is that we mean by strength. So a shear strength can be defined as the maximum or ultimate stress that a soil can withstand without undergoing large deformation or failure. And an undrained shear strength is basically the shear stress where the shear-induced excess pore pressure has no chance to dissipate. And this is really, really important. So therefore, the failure can be said to have taken place in undrained conditions. This means that if you are trying to measure an undrained strength, you have to have undrained conditions. And that was a key component of our discussions in our committee. So what our committee's approach was to review the techniques used in other fields, to compare repeatability and reasonableness of different techniques, including field vane shear tests, CPT, ball CPT, and then the idea of using solids content to measure strength gain, the idea of you're measuring solids content to prove that you're on track for consolidation, and the idea of using pore pressure dissipation to correlate to strength gain, again, that idea of tracking to consolidation. So the results of our work, this took a year of many weekly meetings and discussions and consultations with experts and literature reviews. And we came to a very quick agreement that field vane testing and cone testing were very good methods for measuring undrained deposits. So anything in that brown area, we're like, yep, fines dominated, it's clearly undrained, we can measure it. There was a lot of debate as to, for the yellow and green and blue areas, is it undrained? Does it matter? Is it something that we can measure? And we basically decided that if it is not undrained, you cannot measure an undrained shear strength in it. So we also reviewed pore pressure measurements to show that there's significant technical challenge with using pore pressure as an effective method of measuring stress and strength in the deposit. And David's question actually kind of alluded to some of the challenges we encountered in our literature reviews on that. It's very complex, it is an indirect method, and there's challenges with getting sustainable long-term pore pressure measurements in an active deposit. You can measure it, but can you measure it in the same place with the level of accuracy needed to measure 5 kPa of strength? And we decided that that would be way too hard and give us more headaches than it was worth for this Directive 74 compliance. We also reviewed the idea of solids content, and we were comparing the solids content between CPT data and to see whether or not we could start to see that increase in strength as our solids content changed. We found that it's very difficult to compare those directly and to predict strength directly from our solids content measurements, partially because of the challenges of subsampling that occur with these samples. So we also found that reviewing the use of measurement techniques in other parts of the world, that alluvial deposits and other soft, loose sands are often characterized by cone penetration testing. It's one of the most commonly applied tests. And when we consulted with industry experts, such as Peter Robertson, who's in the audience today, he proposed that we use an idealized CPT curve that would basically say, okay, this is what it should be if it was at 5 kPa undrained shear strength, and if you achieve anything above this, it would be meeting that strength. We decided that as a committee that approach was too simplistic for regulatory requirements, and we were not going to recommend that at this time. So this is some of the example of the data that we analyzed. We looked at 80 pairs of cone test, paired cone logs, missing the word, and their corresponding samples. And we evaluated, we plotted these on a ternary diagram to see where they would fit in terms of what kinds of deposit. So again, this is all based on the actual solids content, fines content that was measured. And then we evaluated them based on this idealized profile that is shown on the right to say, okay, were they in the fluid region, or were they above that red line? So if they're above that red line, they're shown in the red triangles. And that would say that, you know, theoretically they should be well in advance of 5 kPa. Or were they in between the green line and the red line, in which case they might be 5 kPa, depends on what your correction factors are and your soil weights are. And then, or are they definitely fluid, in which case they would be the blue squares. And as you can see, for the most part, if you are in the fluid regions where you would expect to have fluid tailings, we indeed found fluid behavior. So that was good. When we were in the very solid region, so quite dense sands, quite dense clean sands, and fines-dominated materials that were getting up there in solids content, we were finding strong material, again, as we would expect. Our challenge came in the region of overlap, as I show there, where right along that border between sandy fines and transition material and sandy material, which is unfortunately where a lot of our composite tailings reside, there was a lot of overlap between the CPT measurements, whether or not it was fluid or very strong. And that makes sense because very small changes in your solids content or your grain size distributions can make really big differences in how you get grain-to-grain contact and therefore how you get strength. And so it's very challenging to be able to draw a clear line just with solids content. And it's also very challenging to say, well, which measurement would we rely on more? And that's why we ultimately couldn't make a recommendation in this area. So we decided that undrained shear strength, as specified by Directive 74, can only be measured in undrained deposits. And we defined undrained deposits, after some consultation, as deposits having an SFR less than 1.5 or a time to 50% pore pressure dissipation greater than 100 seconds, as measured by a 10-centimeter cone with a pore pressure measurement at the cone shoulder. And this is based on some work that De Jong and all had done. One caveat is that the oil sand standard is to measure with a 15-centimeter cone, in which case you can still use that time to pore pressure dissipation of 100 seconds, but you need to carry out your cone testing at a reduced speed of 1.6 centimeters per second. And this way you could potentially use undrained shear strength in your composite tailings if you can prove that it's actually behaving in this undrained manner. The measurement methodology that we recommended was using either CPT or field vane shear testing. We felt that field vane shear testing is the direct kind of calibration standard, but in order to actually get that calibration standard, you have to push a cone first. And the reason why you need to do that is you need to confirm that you are in fact measuring an undrained shear strength. And so you need to confirm that you have undrained conditions if you are uncertain, and that you aren't in a sand layer. The method of measuring, so CPT, ASTM standard, we felt was satisfactory, and we didn't have any changes to that. Ball CPT, we said that using a ball is pretty much the same as using a cone testing with a different tip, and De Jong and al. Had proposed some modifications to ensure you got good, reliable data, and we agreed with those modifications. And in interest of time, I'm not actually going to read them out, so you will be able to refer to them in my paper. Measurement methodology we found the most challenges with was the field vane shear test. Although ASTM D2573-08 is a great standard, we didn't feel that it gave us the sufficient accuracy and repeatability at the low end of the scale, which is what we're interested in. Therefore, we commissioned Dr. John Howie and Dr. Peter Robertson to write us an addendum to this that they would feel could give us the accuracy in these very soft deposits. Some of the key changes that they made or that are in this addendum are they increased the allowed vein size to 150 millimeters, which happily is the one that we've been using for measuring a lot of these soft deposits already. Keeping the vein area ratios similar, some rules around testing and when that should be. And also, it's really important that you have a load cell that's capable of measuring to that precision of a half a kPa and has been calibrated to do so. So making sure that you have appropriate calibration and you're getting that level of accuracy from your load cell. Now, in the interest of realizing that it's not always practical to, one other thing for the field vane test is that we said we really needed to have that plot of your torque versus rotation in terms of veins, shear stress, and rotation, so that you can actually see what was happening and denote the rates of rotation at various points to ensure that you're actually following ASTM standard on your rates of rotation. So really important to have that documentation and that geared crankshaft. So we did recognize that it's not always practical to have these highly controlled tests, particularly in thin lift situations. So we said that the handheld vane would be allowed as an appropriate measurement method, but measurements with this handheld vane needed to be noted as such, so that you recognize that the level of reliability of those measurements are going to be significantly lower than your reliability of an actual field vane test. For the repeatability and reproducibility, we felt that the ball CPT could give us better than 0.2% of full-scale output. With care, this is better than 0.1%, and there's a lot of argument that this can actually be really quite good if you've calibrated your load cell at appropriately high precision at the low range. Field vane standard, we're assuming that we can generate the repeatability at 0.5 kPa using this addendum. So in conclusion, we felt that CPT tests are appropriate to characterize all deposits, and they could really and should be used to provide the stratigraphy of the deep deposits or mixed deposits, so you can ensure that you're measuring your undrained deposits appropriately. But we couldn't measure an undrained shear strength in these deposits. If it's not undrained, you can't measure a strength there that is an undrained shear strength. Handheld vane testing is an appropriate technique. Other tests can also be used so long as they can find a good, suitable correlation to these CPT or field vane tests. And so we left that open as, however, if you can show a good correlation and the regulator is happy with it, we're happy with it as well. And it's important to note that this threshold of 5 kPa is really at the low end of shear strengths typically measured, and you have to take a lot of care with getting good measurements here. So we could not agree on an equivalence to Directive 74, so other measurements in these deposits. And we recommend that to assess the repeatability, reliability, and meaning, perhaps more data should be analyzed, particularly in these overlapped deposits, looking at those grain size distributions and seeing if we could get some more reasonableness out of the data. And I know I'm running out of time, so I'm going to end there. So thank you all, and again, thank you to the members of my committee and the consultants who helped us, including John Sopkovich and the team at Thurber.